Hello, and welcome to this presentation, Decoding SpaceWire with MXO series oscilloscopes. In this presentation, we'll show how to use Rohde Schwarz MXO series oscilloscopes to decode SpaceWire serial data. This presentation assumes a basic familiarity with the operation of MXO series oscilloscopes, as well as a basic understanding of the SpaceWire protocol. If you're unfamiliar with either of these topics, or if you'd like a brief review, you might want to watch the presentation Getting Started with MXO Series Oscilloscopes and/or the presentation Understanding SpaceWire before beginning this presentation. Rohde Schwarz MXO Series Oscilloscopes support a wide variety of serial decodes, and SpaceWire decodes are enabled by the software license K530. Decoding can be performed using any of the analog channels, with one channel used for the data signal and one channel used for the strobe signal. In addition to basic display and decode of SpaceWire serial data, the MXO also supports numerous other useful functions. Characters can be shown individually or in a table, and the MXO can trigger and filter based on SpaceWire field values or on error conditions. Decoded characters can also be exported in a variety of formats. The first step in decoding SpaceWire with the MXO is to select Bus from the list of items in the bottom right corner of the screen. Then select SpaceWire from the list of available protocol types. This will also create a small box labeled SpaceWire in the signal bar near the bottom left corner of the screen. This box can be used as a shortcut for configuring decode parameters. The next step is configuring the source channels, and this is done under Setup. As you should already know, SpaceWire links consist of both a data signal as well as a strobe signal, and the channels connected to each of these signals must be configured. The low-voltage differential signals for SpaceWire links are normally probed using differential probes, one connected to data plus and data minus, and the other connected to strobe plus and strobe minus. In some cases, single-ended passive probes can also be used by connecting the probe tip to either positive or negative, and the probe ground to the cable shield. One other parameter is the minimum gap, which is the minimum time between two packets. Other channel or probe settings, such as probe type and parameters, are chosen and configured through the standard MXO channel configuration menus. This might be a good time to pause for a moment to talk about channel settings. Before starting decodes, it's always a good idea to first check that the SpaceWire signal or waveform is correctly on screen. In this example, the signal appears on screen with appropriate vertical and horizontal scaling. The most common issue in serial decoding is incorrect vertical and horizontal settings, such as the wrong time base or volts per division settings. So it's best to visually verify that these are set appropriately. Another potential issue in serial decoding is too small of a sample rate. At least 2.5 times the DUT clock rate is the standard recommendation, and it's important to keep in mind that SpaceWire can run at different speeds, up to a maximum of 200 megabits per second. After verifying that the input channel levels and time base are configured properly, the next step is setting thresholds and hysteresis values for the data and strobe signals. These are voltage values that are used to differentiate a logical 0 from a logical 1. Here, the data channel threshold is set to 0.5 volts with a hysteresis value of 0.1 volts, and the strobe channel threshold is set to 1.5 volts and the same hysteresis value. Note that enabling Show Threshold lines can make it easier to determine whether these thresholds are correctly configured for the measured signals. Once thresholds have been set properly, decoded SpaceWire characters will be displayed together with their analog waveforms in the upper portion of the screen. The lower portion of the screen contains the result table, which shows summaries for all of the decoded characters within the capture, as well as bit-level decodes of each selected character. The display settings can be customized in a variety of ways. The decode table can be turned on and off, and we'll look at the decode table more closely on the next slide. The decode layer is shown along the very top of the screen and can be set to off or to several other formats. For example, interpreting the waveform as edges or as logical bits. The default format is showing the data with each field having a different color. These fields can be displayed in different base formats, such as decimal, hex, etc. Now let's take a closer look at the decode table, which is typically in the lower portion of the screen, and which shows detailed information for each SpaceWire character. This table contains information on a per-character basis, including the index, which is the character number, the state, which shows if the character is OK or errored, and the start time of the character. The type of character, null, data, etc., is shown as well. For data characters, the data field is shown in the user-selected format, and the data rate is also displayed. As mentioned earlier, clicking on a character will bring up a decode showing each field in that character. Our next topic is triggering. Although it's possible to trigger only using standard waveform type triggers, the SpaceWire software trigger provides advanced functionality. To configure this, we must first configure a standard trigger type, such as an edge trigger, and then a SpaceWire specific trigger. The software trigger can be configured to trigger on specific character types and field values, as well as to trigger on error conditions, such as EEP characters. Let's look at an example. Here we've configured our SpaceWire software trigger to trigger on an end-of-packet character. As a result, the MXO triggers when it sees an end-of-packet character in the bit stream. Note that it's possible to trigger on multiple events and/or to trigger on specific character values. Filtering is similar to triggering in that it identifies characters that meet certain user-defined criteria and then only displays those characters. As with triggering, the specific SpaceWire fields or field values can be selected and configured for use as filter criteria. Filtering only on different error types is also supported. Note that the values for a field can be entered as specific values or as a range of values. Here's a quick example. With no filtering applied, our decode table shows many different types of characters and codes. Applying a filter for time codes causes the decode table to only display these types of messages. Before we conclude this presentation, it's worth noting that the decoded results can be exported by choosing Export from the Serial Bus menu. The supported export formats include HTML, CSV, XML, and Python. The CSV example here shows the types of data in the export. This includes timing, character type, etc. for each individual character. Let's end with a brief summary. The K530 option enables SpaceWire decodes on MXO series oscilloscopes. All SpaceWire protocol parameters are user configurable, and decoded data can be displayed in various formats, with both the waveforms and in a decode table. The MXO also supports a wide variety of trigger and filter types, such as specific values or ranges of values in characters, and/or on different types of errors. Decoded data can also be exported as CSV, HTML, and a number of other formats. And finally, remember that it's a good idea to check basic oscilloscope settings, such as levels, thresholds, time base, etc., before starting decodes. This concludes our presentation, Decoding SpaceWire with MXO series oscilloscopes. If you'd like to learn more about serial protocols, decoding serial signals, or oscilloscopes from Rohde Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.